Hello everyone, this is Rashida. Welcome to my channel. My today's video is going to be on the last video on this feature selection mini-series. We are going to discuss the wrapper method today. Just a warning, it includes a little bit of statistical concepts in it, but the good news is even if you don't know the statistical concept very well, you will be still able to use that. And I will show you how you can use that. Because this is not a video on the statistics concepts, we will only limit it to the usage of those concepts. You will see how simple is that once we will work on it. As the other videos of this mini series, I'm still using this housing1.csv dataset, which includes these kind of features: the price, area, bedrooms, bathrooms, stories. We can see all the features by using this df.column. So these are all the features in this dataset. Let's assume the price is the target variable and the rest of the variables are training features. That means we want to predict price using all these other features. And in this video, we will see how to use a wrapper method to find the best features to predict price. Here we define x and y. Because price is our target variable, we are going to exclude the price from the df. And also this unnamed 0 feature. This is 0, 1, 2, 3, only the row number. So this is also unnecessary. So I am going to drop unnamed 0 and price, these two columns, and then the rest of the variables are going to be our training features for now, and y, the target variable, is going to be df.price. So for this video, I will use Statsmodel library. If you're not too familiar with Statsmodel library, you will get to know about it today. If you use scikit-learn library before, what we are going to use today, that's going to be very similar to the scikit-learn library's machine learning models. Let's see. So model equals to sm.ols. So what is sm.ols? Let's have a brief look in that. This is the documentation. I have the link in the description box. As you can see, this is a linear model. Okay, and OLS, what is OLS means? OLS means it's ordinary least squares. So it uses the ordinary least squares method for the linear model. And there are other methods. You can see GLS, generalized least squares. Then all these other methods, WLS. Please feel free to go through all of that if you're interested. But today we're going to use the ordinary least squares OLS method here. And you can see sm.ols, and then you pass y and x that we defined here. And you can see that there is a simple difference with scikit-learn libraries models here. Usually we passed x and y in the fit method in the scikit-learn libraries machine learning model, but here we passed x and y directly in the OLS method itself. And you see we've put y, the target variable, first and the training features. And in sklearn libraries models, we usually put x first and then y. So just be mindful of these little differences, but otherwise it's pretty simple and pretty much similar to the scikit-learn libraries models that we already worked on before. So the reason I'm using the Statsmodel API is I can get the p-values. So model.p-values, these are the p-values of all the features. So this p-value is the statistical concept, as I talked about in the beginning, that we have some statistical concept in it. So if you're not too familiar with statistical concept, you can still use this method. Just let's see how we can do that. Here I am putting all the column names, all the training features in a list and saving it in selected features variable. And why we are doing that, we will see it soon. This code block will give us the best features finally. Let's go through it line by line and see what we're doing here. We will delete the features one by one based on the p-value, and finally we will keep the best features. So while length selected features is greater than 0, while we have at least one selected features, what we do. So we are just repeating this method. You see the model, okay? Just do the model sm.ols yx.feed as we did before, and then p equals to model.p-values. So we have all the p-values for each features the way we had here, and what we are doing, we are just saving it in this p, and p max is the max p, so this gives you the maximum p-values. And then feature underscore p max is p.idx max, that gives the index of the maximum p-values, okay? And if p max is greater than 0.01, here we are putting a threshold of 0.01. You can use this threshold at 0.03 or 0.05 or even 0.1. But I wouldn't try to put this threshold too high. Like I'm not going to put it 0.3. I probably would use 0.2 depending on the case. So there is a trial and error here. You have to check what works for your project. So for this one, 0.01 was good. Now from selected features, I remove this feature Pmax, the maximum p-value that is still greater than 0.01, the threshold. This is another reminder about p-value. If the p-value is smaller, the feature is better. So when we did with correlation matrix, we saw if the correlation is higher, the feature was better. But in this case, it's opposite. P-value is lower, the feature is better. So we will go and see P-max and find the index. And if we see the P-max is still greater than our threshold, we just delete that feature. After removing the feature with the maximum p-value from the selected features, we do X selected features. So this time it will be a new set that already removed the maximum p-value features. If we do not have any more feature left where p-max is greater than 0.01, then we break. So finally we get the selected features. And here you see we have 10 features left. In the beginning, we had 12, so we removed 2 features. Please try with some different threshold, like 0.03 or 0.05 and see what happens. Or maybe try this method with a different dataset. So that was all about my wrapper method. And this is also the end of this mini series of feature selection. We talked about 4 feature selection methods, and please feel free to use all of them. Because as I said in the beginning of the series, that usually it is a good idea to try different feature selection method and then make the decision on which features are best for your model. That's all for today. If you like this video, please like, comment, share, and subscribe. Thank you so much for watching.